So let's look at some review questions from chapters 3 and 4. The first couple right here are pretty easy. Let's just answer these anyway. What's the y-coordinate of the ordered pair? So I can just say the y-coordinate of this ordered pair is -6. What's the x-coordinate of this ordered pair? The x-coordinate's the first coordinate, so -4. Okay, nothing too fancy about those. Alright, now when I plot these ordered pairs in the system, let's just plot each of them. It's helpful sometimes to label them, so I might plot this one right here and then label that one as 2, 4. Again, it's a little bit messy because my marker is really thick, but that's okay. Plot this one down here, 3, -1. I'm not going to label them all just because it takes a little bit too long in the video, but it's helpful just to label them. A lot of times they're labeled A, B, C, D, and you can just write A, B, C, D if they're already labeled. Okay, so we've got each of those plotted right there. And so one thing to keep in mind is just make sure you do have a large dot. Tiny dots I might not be able to see unless they're a different color like this one right here. But if I had like for example, a tiny black dot somewhere, I might not be able to see it. So just a large dot's good for drawing something on paper. Alright. The next example, these ordered pairs are just not organized in a table. I still plot them the same way, so you can imagine these being written as blank, comma, blank in each of these. So I'm just not going to plot these. We've already seen how to plot the ordered pairs. And this one right here, consider this figure, find y when x equals -2. Not a whole lot of work to show here either. I'm just going to look for the x value -2, identify the y coordinate, it's -1. So I'm going to write y equals -1 in that space. Find the y when x is 6, so I just trace down, find the y, looks like -5. Let's see, y when x is, or find x this time when y is -4. So y being -4 had an x value of 4. And find x when y is 1. When y is 1, x is -6. And then the x and y intercept. When I write the x and y intercept, I would prefer to see both coordinates of the point. On my math lab, often the y-intercept is just given as the y-coordinate, but we're going to write the ordered pair right here. An ordered pair would be 0, -2. 0, -2. X-intercept, the ordered pair right here, would be -4, 0. So let's go for the entire ordered pair right here. I know oftentimes in my math lab, it goes back and forth between requiring an ordered pair and requiring just the coord. On the next page, we want to graph each of these equations. Now when I graph them, my preference is to use slope-intercept form. This equation right here is already in slope-intercept form, so I'm going to start by putting my dot at 2 for the y-intercept. Right, that's my y-intercept. And then my slope is -3/5, so from there, I'm going to count down 1, 2, 3 over 5. Okay, very helpful to have showing those dots. Showing those dots is a good first step. Again, if I just draw like any old line in there, you're not going to get full credit for this. So what I would like to see, let me erase that line real quick. What I would like to see is if you do not have a ruler, make sure that you count in both directions. So go up 1, 2, 3, and back 1, 2, 3, 4, 5. Okay, if I show all the dots on the equation, then it's okay just to try to connect them the best you can without a ruler. Better yet, though, is to bring a ruler or a straight edge so that you can connect those into a straight line. Let me see if I can do it. Let me start right here. There. Okay, so connecting into a straight line is the best. Without a ruler, though, it's very important that you have all 3 of those green dots right there. Just the first wiggly line I drew, even with the 2 dots shown, doesn't graph the equation. Okay, so let's do this again on the next one. On this one right here, y is not solved for. So my first step would be to solve for it. 3x minus 2y equals 2. I'm going to subtract that 3x from both sides. So that gives me -2y equals a -3x plus 2. And I'm going to divide everything by a -2. -2, -2. So what my y is equal to 2 negatives, make this positive 3/2 x. A positive and a negative makes -1. So I'm going to do my y-intercept, big dot right here at -1. From here I'm going to go up 1, 2, 3 over 2. I'm going to dot right here, up 1, 2, 3 over 2 again. And I'm going to go down 1, 2, 3, back 2. And again, down 1, 2, 3, back 2. It'll put me off the graph, but it gives me something to think about when I'm connecting those. So again, we just want to connect straight through all of them. And the more dots I have, the easier it is to get a quick graph. Okay. What do I do if I'm graphing an equation like x equals 2 or y equals -3? Okay, so for x equals 2, looking at this x value, positive 2, and there's no y requirement, but I do know that I can't go left or right at all, so I've got to be right on x equals 2. So I've got that vertical line to x equals 2. So just a dot, just a point, it's not going to do it. I've got to have a line going all the way up and down right here through x equals 2. Right? My x values are always 2. Same thing here. This one's going to be horizontal. The y value has to be -3. Can never go up or down, just must be through that y equals -3. Okay, so again, a single dot, it's not going to work. It's got to look just like this. It's got to go all the way through that graph. Okay. Some more things here. We're looking at finding the slope of each of these lines. So we know the equation to find slope. So we're just going to use that here. Anytime I have 2 points, it's appropriate to use that equation to find the slope. And again, we do have to have this one memorized. So I'll write the equation up here. It'll be y2 minus y1 over x2 minus x1. So -4 is my y2, minus 3 is my y1, over 2 is my x2, my second x coordinate, minus -1, which is my first x coordinate. So I've got -7 over 3. That fraction does not reduce. I can't finish the division, so that's my slope, my final answer for this one. Alright? So if I have 2 ordered pairs, I need to use this equation to find the slope. If I've got the equation of a line, to find the slope, I just need to solve for y. Solve for y, because y equals mx plus b, slope is going to be the coefficient of x. So 2x minus 3y equals 6. Subtract that 2x, subtract that 2x. Alright, so we've got minus 3y equals -2x plus 6, and divide everything by a -3. Divide by -3 everywhere. So y equals negative makes this positive 2/3 x minus 2. Again here, just solving for y is not enough. That gives me the equation, but it's my job to, the question asks us again to find the slope. It's my job to state what the slope is now that I've solved for y. So my answer to this one is m for slope equals 2/3. So I need to answer it like this. Okay, next we're still working on finding slope, part C right here, of the equation y equals 3. So this is already in y equals form. Remember that equation was y equals mx plus b. And this one right here, there is not an x. This whole mx part is gone, which is letting me know that that's 0, right? 0 plus 3 is 3. So that tells me that the slope right here is 0. Okay? Now for part D, that's different because it's x equals -1. So the question of x equals -1, if I were to solve for y, there's no y to solve for. I can't do that. So the slope right here is undefined. Don't get those two confused, 0 and undefined. They do not have the same meaning. Another way to think about it, this one right here is a horizontal line, and a horizontal line will always have 0 for its slope. Because if you're walking across the floor, you can get there without picking up your feet. You have 0 for your rise. But x equals -1 is a vertical line. If you tried to walk up a vertical line, you couldn't do it. You couldn't be able to walk up the wall, for example. So that's undefined slope. Okay, so keep those two separate. Find the slope of the line whose graphed right here. This is actually the easiest to do, but I might do it by starting and considering some ordered pairs. Now I want to be careful because this one right here is not an ordered pair at 2, -2. It looks close to the corner, but it does not go through it. Okay, I believe it does go through here, but let's make sure we can find another one that it goes through. That's a good one right there. And maybe the corner right here. It's looking like it's going through these ones. Looking like it's going right here and right here. Okay, it's a good idea to find a couple of ordered pairs just to make sure that we don't make a mistake and use something like this one right here where it's not going through that ordered pair. Alright, so to find the slope, we're going to count rise over run, or write down the ordered pairs and use them to rise over rum. I don't know what I'm thinking about. Rise over run. And then we're going to use the ordered pairs to count. Okay, so 1, 2 for rise. So 1, 2, and then 1, 2, 3, 4, 5. Okay, now just to verify, let's go from 2 to the other ones we found to make sure it is 2/5. 1, 2, 1, 2, 3, 4, 5. So it's always good just to check it in 2 different spots before we give our final answer for this one. See what we have next. What is the slope of a line parallel to this line right here? So remember that parallel lines have the same slope. So I can see that the slope of this line is -1/5. So a line parallel will also have a slope that is -1/5. The slope of a line perpendicular to this line. First of all, I need to find what that line's slope is. So we're going to solve for y. So 2x minus 3y equals 6. Subtract the 2x from both sides. Don't lose your negative right here when you write down that -3y equals -2x plus 6. I need to pick my pencil up a little bit more with my negatives. Okay, divide by -3 everything. Okay, so that gives me y equals 2 negatives, so it's positive 2/3 x minus 2. Okay, so the slope of this line is 2/3. So if I was parallel, I would still say 2/3. But I need the slope of a perpendicular line. So it's opposite, which means that that one's positive, my opposite's negative. Reciprocals. So the reciprocal of 2/3 is 3/2. So that's going to be the slope of a perpendicular line to this one right here. Alright, I'm going to stop right here and start the next one on problem 9.